Hey, welcome to D-Lab. Today I've got a 67 Fender Deluxe Reverb on the bench. Comes to me from a fellow in Pennsylvania. The complaint is, he says when he first switches it on, it grumbles, crackles pretty loud, then quiets down somewhat. Okay? Sounds like some microphonic tubes, possibly bad connections in the tube sockets, etc. But the other good thing is, this amp has never been worked on. It's untouched. So let me give you a quick tour and I'll give you the lowdown of what it's going to take to get this thing back to life. Alright, here we are top side. As you can see, everything is original. Tube sockets look excellent. I've already popped the top of the cap compartment. You can see they're the old original, the 16 microfarad caps. We're going to change those out with some F&Ts. Alright, let's go bottom side and see what we need to do down there. Alright, bottom side. Obviously the two-prong cord has to go. We'll install a grounded one. Remove the death cap. Eyelet board has a lot of caps that need to be changed, but what I like to do is the grid caps have to come out because if they leak it'll damage your output tubes. These Mallory electrolytics and these little guys here have to go. I try to keep the original tone caps installed, alright, so that maintains some of the amp's mojo. Wiring looks excellent. No signs of a beer being spilt in it or nicotine. A super clean Deluxe Reverb amp, right? Front panel, got all the original knobs. Which really looks good. And it's sitting on my amp holding apparatus made by Tony Guzmano. So we're going to start the rebuilding process by removing these original 16 microfarad caps. If I cut the leads close to the cap, and that is going to give me these pigtails to make J-hooks in, like so. Oops. And then the new caps, we'll do the same thing here. I'm going to hook them together and solder them, okay? I prefer to use these J-hook connections because then I do not interrupt the original connections on the board. What's nice about these amps is all the positives are facing you, so you don't have to sweat it when you're replacing them. Okay. So I pop them out, take a new one, make sure it's equal, trim him up, J-hook him in. So what I'm replacing these with are F&T 22 microfarad 500 volt caps. Okay. I don't put in the 16 microfarad caps. You can if you want. They're harder to find, and you'll gain nothing by staying at that lower value capacitance. Okay. That's how I do it. You don't have to do it that way. I don't need people writing in saying, oh geez, why'd you do that? Well, whatever guys, that's why I do it. I just do it, okay? I'm also not going to test any of these caps because the owner wants them all replaced. So why should I check them, right? Just going to put in a fresh set. I was telling my wife this the other day. It's like you take your car in to get tires put on your car, right? So you go into Discount Tire and you say, I want a new set of tires. What are they going to do? They're going to put in a new set of tires. They're not going to say, hey, this tire you could probably get another 5,000 miles out of. No, they're there to sell tires. I'm here to sell caps. So I got the remainder of them crimped into place. Solder up these little pigtails. And then we'll move to the bottom of the amp. So using this J-hook method, you can carve out the old, have the new ones installed in about 10 minutes. Alright, now we're going to move to the bottom of the amp, first thing I'm going to do is get that power cord off of there. Cut out the old death cap. Sometimes it's easier to get to the low side of the lead from the top of the chassis, because you really can't get your pliers in there. So let me flip it and remove that. Alright, so the death cap is now removed. Now we're going to put in the grounded power cord. What's nice about this one is actually a vintage cord. So it's got like the old cloth runners in here. It's not like these new ones that have that crappy nylon stuff. These are the real McCoy. I've got a few of these left. Now the old power cord had a restraint back here, okay? So if you look at the difference in our cord dimensions, it's obvious I will have to drill this out to get the new restraint in that holds this cord. That's just part of the deal. So there is the original cord restraint. Here is the one that I need to put in. Obviously it will not go in the hole, so I'm going to take a stepper bit, open that up a little bit, and get the new power cord on. Well, here's a little tech tip. Don't drill this hole to where this restraint will drop right into place. If you do, it's going to fall right back out when you put your cord on. So I make sure that these are snug. You see how it won't go in there? Then I take a Dremel tool and I actually put little square edges here, here, and here, here, right? And that way, if you take a look at this restraint, it's not exactly round. It's got flat sides, and there's two round edges that have the grooves that bite. You want to give this hole that same type of dimension. Then she'll go in and it'll be just like stock. Alright, so see how the new hole looks? It almost looks like an oval in a way, okay? So now, once the cord's in there, that's going to spread out and she'll lock in. Alright, so I'm ready to put the cord in. So I understand that they make a tool for installing these restraints, so you don't have to struggle like this with a pair of pliers. But I have yet to find that tool. Okay, so yeah, I got to struggle with this to get it in, but it will pop in. But if any of you guys know where that tool is, I want one. Alright, it's in. That was not a lot of fun, but it's tight. It's not going to pop back out. I have a lot of amps come in here where people over drill that and the cord just falls back out. So it's worth taking your time, get your little Dremel tool, adjust that hole properly, then your customer will be very happy. I've pre-tinned my wires on the power cord. Now we're going to solder the ground direct to the chassis. I don't use crimp-ons and put them under bolts of transformers. I solder direct. I did notice that there's a date here, 5/2 of 67, with somebody's initials that built this thing. We're going to make sure not to interrupt that with the ground connection. So yep, this is the famous Snozeramus iron, big old Unger with an extremely hot tip. So I've already ground the chassis a little bit so that the solder will bite into it. So there it's tinned. Get the ground wire in there, wet the tip a little more. There she is. Nice secure ground. These Ungers are a good investment, guys. Alright, so now we need to get these old leads out of this AC socket. You can see Fender just poked them in. So that is what I'm going to do with the new ones. Alright, so I've already cut these and I've put little angled cuts on the end of the wires so they'll poke in there easily. Alright, line cord connections are done. Now I'm going to get my meter in here. Maybe you can see this. This is another thing you really need to check on your amps. And that's these 470 ohm resistors for the screens. Remember, it should be 470. That one's 570 something. This one, if I can get on it, there we go, 640 ohms. So these are way out of tolerance. Always check these screen resistors, because if a tube has failed in the past, a lot of times you'll actually see a little dark area, and some of these are cracked right in two. So don't forget about those. Alright, now that I got the 470s out of the way, you got your little grid resistors down here. Should be 1.5K. Normally, these are alright. That one's at 1.8K. That one's at 1.7K. So I'm going to go ahead and change those while I have access. Alright, so I found a beautiful set of Allen Bradley 470 ohm resistors to put in the screen circuit. Now we're going to change these two grid caps going to the finals. A couple reasons. Number one, when they leak, they can damage your output tubes. I've got to put a little solder in here to get this flowing. Secondly, these caps are only rated at 400 volts. And the plate voltage is higher than that. Okay? So they're just asking to fail. I never understood why they only put in 400 volt caps. Now I'm pulling these out completely. I'm not J-hooking in the new ones, okay? Because these eyelets were designed for you to be able to replace your components directly, okay? Another thing I need to bring up while I'm doing this is I know a lot of you have been emailing me and you want me to take on a bunch of new projects. Some projects are long-term projects. Unfortunately, my friends, I still have a day job. I'm gone about 10 hours a day. So I just don't have the time to devote to long-term projects. I know some of you may get a little frustrated about that, but I'm lucky to have like 2 hours a night to work in the shop. And then, you know, I've got, like everybody else, family, and, you know, I got a lot of distractions. So it's hard for me to get to all of it. It's hard for me to get to emails. Okay? So sometimes you guys might email me and it'd take me days to get to it. No offense. Number one, I'm a terrible typer. Number two, I'm scrambling to get these projects done. Alright, we're almost wrapped up here. Get these new capacitors in. Then I'm going to move down the line here and change out those electrolytics. And after that, I might actually pop in some tubes and see how the amp is performing at this point. Alright. So anyway, I always return all these caps to the owners. So if you guys want to say, hey, this was my original cap, how cool is that? But at a minimum, guys, you have to change these grid caps. Good or bad, change them. Alright, I've changed the caps on the eyelet board that I normally do before the initial check. So let's get some tubes in it and see if the Deluxe comes to life. Here we go, initial test. I have a new set of Tungsol 6v6s, some Savtech 12AX7s. I was able to keep his original 12AT7s, which is nice. They were, what are those things? Telefunkens, right? So I'm going to bring the amp up slowly on a Variac. I got a meter monitoring the current through one of the output tubes. So if something goes wacko, I can catch it. I always like to bring these up initially on a Variac to charge the new filter caps. So I have standby and power on at the same time. Okay. So the high voltage is coming up at the same time that the amp is powering up. There's about 60 volts, drawing about 1/4 of an amp. No smoke signals. I don't see the dial light on, but I'm sure it's probably burned out. No worries. I'm going to keep going until I see some current on my meter across the little shunt that I installed. And I do have a dummy load connected at this point. I do not have a reverb unit. There's our current. So I have 1 ohm resistor, so what's on the meter is direct current of the tube. There's about 15 milliamps right there. I want to make sure she comes up and stabilizes. Going into with about 80 volts right now. So that would tell me that more than likely the current is a little bit high. I may have to bring the bias back a little bit. Yeah, there's about 20 milliamps. I don't want to run it hard initially, so I'm going to bring back the bias a little bit. But she's alive. Alright, she's plugged right in the wall now, and I set my bias for around 21 milliamps. Looking at the scope here, playing with the volume control, make sure I'm not seeing any crazy noise. She looks good. Let's get a signal in it. I'm using my leader audio generator as an input source for right around 1000 hertz. Standby's on, there's a scope, and there's the signal. Looking good, nice and clean. Let's check the normal channel. Yep, I can actually hear it singing out of the dummy load. So the amp is working, the bias is holding steady. We're on the road to recovery on the Fender Deluxe Reverb. Alright, so I've connected a reverb tank, and we're going to verify that reverb and tremolo are operational. So we still have our signal applied. So here, ground out the old tremolo input. See what we got. Oh yeah. There's my speed. There's my intensity. So that's working well. Now we'll go over to the reverb. Turn off the tremolo. Okay, so here's the signal without reverb. I'll take up to about 3. Vary my frequency. So the reverb tank is working. There's back to 0. And there's some reverb, so yep. She's looking good. So at this point I'm going to do what I call blueprinting out the amplifier. So I can read all these resistor values, but if you can't, what you do is you take your schematic, you look at what the resistor values are supposed to be, measure the ones installed, and make sure they're actually what they should be. All these over time drift out of tolerance, especially these 10% resistors. But you don't want to go in here and just blindly start changing them out, okay? It's very labor intensive, so you go through and you buzz them out, right? So here is 100K resistor. I'm on the 2 meg scale, so let me go down to the 200K scale. So here's 100K, 103K. That's alright. Here's another one. 113K. So he's a little high. These are the plate resistors for the first 12AX7. 101. So you get the point. You go down, you check these resistors, okay? Any of them that are way out of tolerance, I'm going to change, like that one. That's 120K. That one's about 115K. So those two should be changed. The reason you want to do this is if you have real high or real low value resistors, it changes the gain of those stages. So I'm going to go down the eyelet board, check all the resistors. Any in question I will change out. and then this amp will be ready to be demoed. Right now I'm checking the two 1.5K resistors going to the first 12AX7. You can see they're definitely out of tolerance, like 2K. You get the point. I'm going to change the resistors, I'll retest it, and then we'll shoot a demo. Well, I've changed out all the out of tolerance resistors that I found, so now I have the amp powered up. I'm going to look at it on my scope. I'm going to do the old D-Lab tap test and see if there's any intermittence, because the owner did say that at times his volume would go in half and then recover. That was probably a bad tube, but I still need to check it. So you can't see the signal on the scope, but I can. I just go through, tap on the board, make sure the sine wave does not drop out. Looks really stable. I believe there's no issue with dropouts with the amp.
Hi Bob. Terry just finished up your Deluxe here. Gotta say, dude, this is a beauty. We get some nice amps in here, and I know nice amps. This is a monster. This is a really nice amp. Especially not Terry's. I don't know what it sounded like before, but Terry did a wonderful job on this amp. And I gotta tell you something. Some of these amps, the normal channel has a little extra bit of magic. It has a lot of ringing, sustain that most of them don't have. This one's got it in spades. Baby, sounds nice, Bob.
Yeah, let's check out the reverb channel real quick.
Check out the reverb channel. Here's a demonstration of your vibrato and reverb channel, and it's sounding great.
That should be in the Kuzmano collection.
Sam should be in my collection. This is a nice one, Bob.
Yeah.
You're a really lucky dude. This is a great amp.
Cool. Thanks, man. Yeah. Well, the amp passed Tony's test, so D-Lab is going to take a mission accomplished on the Blackface Deluxe Reverb amp. Next one coming up, you guys are going to love this. I've got a 1962 Princeton. Came here all the way from Hawaii. Problem is, the transformer went up in a ball of fire. Okay, so this is going to be a great project. Stay tuned for more from D-Lab Electronics.